All right, can folks in the room actually hear me at the back? Someone wave a hand. Thank you. Perfect. We're about 4 more minutes here before we can start. In the meantime, maybe I can ask you guys, how you guys are doing. Are you guys enjoying Build so far? Did anybody check out the HoloLens booth and the stuff HoloLens can do? Nobody? I think it's here somewhere. We're not allowed to go there, actually. It's only for customers. I mean, I would love to play my hands on it, but I just haven't had a chance. Yes. I mean, I don't have it, but that doesn't mean, I'm sure, there must be, an SDK. I know very little about it. It was, a very hush-hush project. But it looks pretty cool. So just as a quick survey here, how many people actually today develop stuff using C++? Are you guys all passionate C++ users? Perfect. That's a good crowd. And how many of you guys are actually building mobile apps? Wow. How many of you guys build for platforms other than Windows? Woohoo! Perfect. So if that is the case, you guys have come to the right talk. Thank you for choosing us over some of the other ones available at this time. We have about 1 more minute, then I can actually officially start. Yes, everybody come here. Perfect. More people coming in. Great. I believe you can actually start. So if you guys can settle down, I'm actually going to get started here. Perfect. So this talk is going to be about building cross-platform mobile apps using C++. This is something new that we've launched with VS 2015. To introduce myself, I am Ankit Asthana. I am a program manager. I work in the Visual C++ team. And this session essentially is going to be a bunch of slideware, very few slides essentially, to just give you guys an overview of how mobile platform technologies look like, what are some of the strategies, and then we'll get into doing some cool demos. So I want this session to be interactive, so essentially please participate when I ask you guys questions, because part of these sessions is not only giving information to you guys, but it's also getting information back for us, so we can build the right products for you guys. So let's get started. So evaluation, yes. So please do fill the evaluations here for each breakout session. They're important. It helps the speakers like myself improve, and also helps us if you're actually presenting the right content. That's useful for you guys as you go through the sessions, so please take time to do that at the end of the session, hopefully good. And with that, I'll get started with the first slide here. So the first slide here is about more platforms, more opportunities, right? So if you take a look at the current mobile user, which I'm sure all you guys are, we all have our favorite set of applications. And we want to be able to use them across a wide set of devices. I might have an Android phone at work, but I might have an iPad at home. And I want to be able to use the same app across these two platforms. As a result, developers, which is you guys, want to be able to target more platforms, because targeting more platforms for you guys means more money or opportunity for someone like me if I'm targeting more platforms to get famous. So if you go ahead and you want to design your application, your mobile application, there's multiple ways you can go about this. The first approach you guys can take is essentially the silo approach, which is basically you can go ahead and build the application on each platform in the popular language on the platform. So that would be like C# on Windows, Objective-C, and now Swift on iOS, Android on Java, and so on. So obviously, a lot of apps are written in this manner, and there's benefits to this approach. Now, if you're using this kind of an approach, what you guys can do is that you guys have the full native experience. You guys have access to the platform SDK, which allows you to access all platform APIs and leverage the full feature compatibility on that particular platform. There are also some negatives with this kind of an approach. So since you guys, now that I've surveyed at the start, that you guys are C++ users, in fact, how many people actually think that what are some of the negatives that you guys can think of here? Anybody in the room? So again, compilers aren't compatible. Interesting. Anything else, sir? Bingo. That's correct. 100% correct. You have to write your app 3 times. So the negatives here, the first one being there is minimal code reuse. Now imagine I'm actually creating a new feature on my application that's been targeting all these 3 platforms. I have to go write it 3 times. I have to write it in C++ or CX in Windows or C# on Windows, write an Objective-C for iOS, Java for Android, and so on. So that's not good. So as a result, your development cost over a period of time increases and so on, right? So let's start with another trivia question here. So the question is, for you guys again, how many of the top 50 applications in the Android Play Store US leverage C++ code? 40. I'll give you choices. So the first choice is none. How many people actually think that in the top 50 applications in the Android Play Store, none of them actually using C++? Okay. How many people think that there's 10% of the applications on the Android Play Store using C++? Woohoo. How many people think there's 40% applications that are using C++ in the top 50? And who's going to be the brave one here and say that 80% of the applications on the Android Play Store are using C++? Wow, we have a smart bunch here. So the reason I had this slide was because the answer is obviously 80%. Surprising. How many people find this surprising? That 80% of the Android Play Store top applications on the Android Play Store in the top 50 are using C++. Well, let's take a look at what these applications are. So again, this data is about a couple of weeks old. So don't sue me if any of the order changed here. So some of the platform-defining apps like Facebook, Candy Crush. There's a couple of Candy Crush folks here at the front. They said don't mention them, but I'm going to mention them anyways. Skype, another Microsoft application. Temple Run, Twitter. All these famous platform-defining applications are currently using C++. Now, if you talk about in what quantity they're leveraging C++, that's actually different. So if you talk about an application like Skype, which is basically truly cross-platform mobile, which targets Android, iOS, and Windows, they have about 70 to 80% of their code written in C++. The same is the case with Office. Some of the other apps like Facebook might be using only a small library or a small portion of their functionality that they're leveraging is using C++. So the mileage varies, but one thing is for sure. All these top 50 apps, there's something in common among them, that they're using C++. Now, C++ from a language perspective is supported on all these platforms. And if I actually go ahead and write my cross-platform code, let's say my business logic of my application in C++, and actually have a lightweight UI on top of that in the platform language, then I can still actually get the benefits that I want from a perspective of full native experience. I get the platform SDK. I get total access to it, so I can actually access any of the APIs. But there's also some other advantages. The obvious one is reuse. What are some of the other advantages that you guys can think of? Maybe some from that side of the room maybe this time. I heard speed, absolutely. Performance. The age-old argument of using C++ over other languages is performance. And that is absolutely correct. C++ code runs directly on the hardware as compared to traditional .NET or Java code. Also, if you want to access the advanced vector instructions or neon instructions on your great Samsung Galaxy S5 device, guess what you're using? You're using C++. If you want to have fluid animations in your games, guess what you're using? You're using C++. Also, if you take a look around, most of the mobile platforms today run on ARM chips. ARM is great for battery life, but it's not so great when compared to some of the Intel counterparts, maybe for runtime performance. Maybe, again. And over there, if you're using C++, every ounce of performance that you get from C++ on those mobile devices is worth its weight in pounds. And that is exactly some of the reasons why those apps that I mentioned there are using C++. I'm going to move on here. These slides will be available for people, just people taking pictures. So now that we've seen what kind of apps are using C++ and so on, let's take a look at how does the architecture look like. So apps like Office, Skype, Bing Maps, Dropbox. I mean, there's a great talk by Dropbox on using C++ cross-platform. You guys should look for it. There's a hyperlink in the presentation as well. All these apps that are there have a very thick layer of their code or their cross-platform code in C++. Office has about 90% of their code in C++. And then you basically go ahead and write your UI or your presentation layer of your software in that lightweight language. It could be XML, Java in case of Android, and then access it using JNI, which is the Java native interface, into your fat C++ layer. And the same you can do for Windows using pinvoke or the Objective-C wrapper and so on. So this is a fine approach. But it has challenges. Now, if you're actually using C++ across these different platforms, there are challenges. So far we've seen that it's actually good. I can actually write my cross-platform code in C++. I have the ability to do that in every platform. We've seen the architecture. Now we're talking about some of the challenges that are there when you're trying to use C++. There is a variety of compilers. Someone earlier mentioned compilers here, right? You see a variety of compilers when you use C++, right? There's the Visual C++ compiler for the Windows platform. There's Clang LLVM and GCC from the Android NDK. There's Clang LLVM, which is the Apple's version of Clang LLVM. There's different build engines. There's different IDEs. There's Visual Studio for Windows. There's Eclipse today for Android development, Android native development, Android Studio for Java, and so on. And there's Xcode, obviously, for Mac. Which brings us to this slide, which talks about some of the challenges that we have. It summarizes some of the challenges that you have with C++. Now, you guys in the room, people who are using C++, I'm sure you guys can locate yourself either in a column or a row and a column, and so on. So some of the challenges here. All these tools, installing them, there's different acquisition experiences. You have to go figure out how to install. If you're talking about the Android platform, you got to install Android NDK, the SDK, and Java. Set up the right plugins in Eclipse so you can debug the code and so on. So there's definitely problems there with having multiple installation experiences. If that's not enough, you guys have to go ahead and figure out how to use multiple build tools. The flags between Clang and the Visual Studio compiler, the Microsoft compiler, are different. There's compatibility issues. The way the PCH works is different, and so on. And of course, there's different build systems. I mean, as we're learning about Xcode build and MS build, to be honest, the only thing common between them is build. So there's actually different build systems that you guys have to use today too. Debugging. So one of the primary reasons you'll see for our experience here that we're going to offer in the next slide is that debugging experience, especially for the Android platform, is not that great, especially the Android C++ debugging experience. Those of you guys here in the room who actually develop an application for Android which uses C++, how many people find the debugging experience is not being ideal? This is actually a few people here, a few people over there. I wear glasses, so I can't really see that far, but I saw some hands there. Also, another thing here, multiple C++ IDEs. There's Xcode for iOS. There's Android Studio and Eclipse for Android. There's Visual Studio for Windows. And if you guys are used to trying out your favorite key bindings and shortcuts and so on that you like and love about an IDE, that's actually hard to keep changing IDEs and so on. So with that said, starting with Visual Studio 2015 RC, we want to share some new news with you guys, right? This is a really exciting time for us from a Visual Studio team. We are, and I worked on this animation last night, starting with Visual Studio 2015 RC, you will start seeing the experience that we're trying to provide for cross-platform C++ developers such as yourself here. Using this experience, you'll be able to easily install all your cross-platform needs. This means that you can actually install your first-party Microsoft software, the templates and the project and build system bits and so on. You can also install all your third-party software, which includes your Android NDK, Android SDK, and Java, and so on. Not only that, you can also manage dependencies and you'll be notified in Notification Manager instead of VS as new versions of them become available, and you can optionally update your bits as the need be. There will be one single C++ IDE. We will offer you that one C++ IDE for all your cross-platform needs. So currently, we're focusing on that fat C++ layer of software, And we believe with this Studio 2015 RC, the IDE of choice will perhaps be the one that we're going to offer. We're also going to offer you, and I'm going to demo this as well, show you some really cool features in a cross-platform space, which allow you to share and reuse your cross-platform code, and also allow you guys to use our state-of-the-art code editing features, some of the advanced features in code editing, for example, refactoring and cross-platform IntelliSense. It doesn't end there. We will also take the same experience you guys are used to today on the Windows platform and extend that from the Android platform. Working with Bing Maps and Office and internal partners over a period of time, we believe we have the fastest Android native debugger today on the platform. And to top this all with, we essentially really believe in you guys having a very fast build, edit, debug cycle. So for the Android platform specifically, we're also launching the Microsoft x86 emulator. It's based on Hyper-V. It's fast. It's super cool. So all this is available now in Visual Studio 2015 RC. It will also be available in Community Edition. At this point, I would actually look for any questions you guys might have so far before I actually go into demos. Does anybody have any questions so far? You guys are all happy, excited? Questions, sir? Yes, sir. How far does it take in the iOS experience? I will answer that question in the last 15 minutes of the presentation, if that's okay. Sir? What do you have to install on the Mac on the Linux system? You'll also see that shortly, if you don't mind. Maybe I should just move on. That might be a better idea. So let's actually go ahead with our first demo of the day. So who here was actually at the Amanda's talk as well for cross-platform? A few folks here. So she demoed this app, and we're going to actually talk about how we create this app and so on. So the app I'm going to show you guys is the More Teapots native activity Android application. This is coming from the Android Native Development Kit. And native activity, for you guys who are not very familiar with the Android platform, is a style of Android programming where majority and almost all your code is C++. You still have a very thin Java layer at top, but that's really for show. So we're going to go demo that. So for doing that, I'm actually going to go move back here and wake up my machines here, and also change my display port here. All right, so if you guys want to try this out at home, or if you guys already have Visual Studio 2015 RC, this is actually a sample. So you can go here. You can see here that I already installed this. You guys can install this as well and try it out yourself. It's pretty easy. So with that said, let's take a look at this project, right? So here is the More Teapots Android project. This has two projects within it. There is the native activity project. Let me expand that for you guys. And then there is the packaging project. The native activity project here contains all the C++ code that you have for this application. And if I take a look at property pages, you'll notice that this is building a dynamic shared library. For those of you guys who are not very familiar with the Android programming, again, this is very similar to building a DLL on the Windows platform. Using property pages, you guys can also view, edit, and modify some other project characteristics. For example, I can go ahead and choose the platform toolset I want to choose. We currently support both Clang and GCC, and this is coming from the Android NDK. Also, you can actually go ahead and choose the target API level you want to use for your Android application. We support up to API level 21 currently. We're working fast on updating these bits as well on the latest API level. All the other property pages here have also been migrated to work with Clang and GCC. So this is something new in our toolchain. So remember, the native activity project is building that C++ library. That C++ library is then getting used up in the packaging project, which invokes the and build system and takes that C++ library and gives you an Android end-to-end application or an APK file, which you can then debug and deploy. So next, I want to show you guys some of the features that we have from a coding perspective. So let's jump into some code here. So I'm going to look for this function called Android main, which is in the more teapots native activity.cpp source file. Now, Android main is a characteristic native activity function. It's almost like an entry point function. It's very similar to an int main function in a Windows 32 console application. So I'm actually going to go ahead and add a log message here, very similar to the one above. Notice as I'm doing this, the Android specific intelligence is lighting up and helping me out here. So I'm going to say this is during the live demo. Here we go. So we've actually done work to enable Android specific intelligence, which lets you not only view the API that you want to use, but also the type information and all that kind of other information. So we've extended this from a Windows platform perspective. All the other features that you guys are used to, for example, if I want to go ahead and look at the definition, let's say for ID, I can use the peak definition window to be able to do this nicely. So I can see here that for this variable ID, it's of type int. I can also use some of the other advanced refactoring features. For example, advanced code editing features like refactoring. So starting with Visual Studio 2015, we also released the ability to be able to refactor your code. Now, that parameter name, I don't particularly like that name. Bad engine, bad demo doesn't sound that great. So I'm actually going to go change that now. So for doing this, I'm going to use the refactoring feature. I'm going to go ahead and say rename. I'm going to change this to good engine, great demo. So notice when I click preview, it actually gives me the uses of this particular type across my source file. I can select or deselect based upon my intuition and based upon where this change is being made. For now, I'm going to click apply and hope everything works. There we go. Now, next, I want to show you guys the debugging experience. So for doing so, I'm going to set up a variety of breakpoints here. There we go. Those are the breakpoints that I'm setting. And that will allow me to show you guys the debugging experience. So notice the drop-down menu here. The drop-down menu is already populated with the VS emulator entry. This is the fast x86 Hyper-V-based Microsoft Android emulator. This is already running in the background, so let me just show you guys this very, very quickly. So that's the emulator running there. Since I already have that running, next I'm just going to hit F5, which will build my application and deploy it to my emulator. So there we go. The application is getting built. And now it's getting copied and installed to my emulator. Notice that the breakpoint that I set was hit. But before we go ahead and look into the debugging experience, let's focus on this tool window on the right. This is the Android Logcat window. Android Logcat is a debugging and a diagnostic tool that Android provides. It helps me view the system debug output. And this could be particularly useful when I'm actually debugging my app when, let's say, it crashes at startup. And it's hard to attach the debugger and so on. So I can add my log messages there and see what's going on. So as a part of our experience, we've also integrated some of the Android debugging tools and diagnostic tools here right into your code editing and debugging experience, as you can see. For now, I'm going to hit continue, which will allow me to show you guys the Logcat message lighting up here. So I'm going to go ahead and continue again. And now, let's start talking about the debugging experience here. Our debugger is an extension, or it's essentially based on the Android GDB, a layer of software that gets provided. And as you can see, it's very, very similar to when you're debugging Windows code. You can go ahead and set breakpoints, all your regular stuff, like the autos window here. Let me expand that. The locals window, all that kind of stuff lights up nicely here. Your call stack will allow you to view the call stack for this application. As you can see, we're in the Android main function. We currently only support debugging C++ code today. You can also go to the breakpoints window and see the different breakpoints that you guys have set here on the different source lines that I have. And if this is not enough, and if you guys are users who are actually using this from a command line perspective, you can also pass commands directly to GDB. So I can go ahead and say debug GDB exec and say BT, which will give me the call stack. And as you can see, that's exactly the same thing that my call stack window was giving me. We're in Android main and so on. So with that said, I'm actually going to go ahead and delete my breakpoints here so I can show you the app running. Yes, I want to be able to do that, and I'm going to hit continue. So that's the app running on the emulator. I have a touch screen, luckily, so I can do stuff like this. And as I mentioned, the Microsoft Android emulator provides, in addition to being fast and based on x86, it also provides me an ability of palette of sensors that I can use. So not only can I actually play around from a touch perspective, I can also play from a multi-touch perspective. So I'm actually going to the multi-touch mode, and then I can do something like pinch to zoom. Or I can string them back together. Let's do this. Here we go. And if I want to bring them back, they will actually come back as the render loop finishes. I can also do other things here. Come on, here we go. I can also do other things here. For example, I can go ahead and change the rotation that I have for my application. I can change the rotation for the emulator itself, and then figure out how my app looks like in different modes, as the user actually prefers to use a vertical orientation versus a horizontal orientation. That's not coming back, so let me just relaunch this. Here we go. It's actually really fast, the loop here for being able to deploy and debug. You can see here now, like I can actually play with the layouts here. But our experience just doesn't end there. The Android emulator also provides you with another palette of sensors that you guys can use for testing your application under great simulated environments, which are hard to reproduce in the real world. So for example, when I bring up this additional tools window, you can see the accelerometer sensor, the location sensor that we provide. So I can actually go look for Space Needle here, and you'll see that come up. And you can use this information in your app and so on. I can simulate my app under different network speeds. So if you guys are big Candy Crush players, playing with your last life there, this might be important, and so on. So using these kind of techniques, you can actually really test your app in a very good simulated environment and make sure that it works for your users, and so on. So with that said, this actually brings me to the end of the first demo, and I'm going to go back to slides. Yes, absolutely, sir. Right. So the question, let me rephrase the question if I didn't get it right. So the question is that, what about apps that have Java code in them? And what about building them and being able to debug them and so on, right? So if you notice here, if when I was doing the demo, I can probably go back to my demo machine here quickly. You will notice that we have two projects here. We have the native activity project and the packaging project. The packaging project essentially integrates with Ant right now and has the capability to build Java code. We yet don't support a language service experience for Java and debugging for Java, but that again is something that we might take a look at based upon the feedback that we get from our users and so on. I hope that answers your question, sir. Thank you. Is there any other questions on that demo? Yeah, sir. Sorry, say that again. And the emulator? Yes, I believe there is camera support there. And if you guys want to meet me at the booth, we can probably work and talk more about that. Sir?
What about performance profiling?
We yet don't have any tools for performance profiling as a part of the integrated VS experience, but there are tools out there that you guys can use on top of our tool chain that you guys might know. I might take just one more question there, actually. So the question is, are any of these tools going to be automated, will provide support for automation, for testing, frameworks, and so on, correct? Yes. So the answer is that, so currently, so this is essentially exactly your MS Build tool chain that we provide, from our perspective. So if you guys want to be able to use, your command line test cases for MS Build and be able to drive the NDK build or drive the build system that we have for Android here, which is based on MS Build, you guys can do that. But we don't have ourselves any test tools that we integrate with from a test, unit testing perspective or automation framework yet today available. So with that said, I'm going to go into my next demo. And by the way, here, I need to switch slides again. Here are some of the features that we talked about here. We talked about building Android native activity, the client GCC toolchain, refactoring IntelliSense, the Android native debugger, Logcat Viewer, and fast emulation. Now, everything that I've shown you for debugging right here, you guys can also bring in your existing Android application from whatever IDE you guys are using and you can debug that in Visual Studio. We provide support for that as well. If we have time, we'll get into that demo. So I'm actually going to go ahead and go to the next demo now. So the next demo here, so this is a cross-platform talk, right? So I wanted to start simple with providing you guys an overview on what we've done with Android. But the next application that I'm going to show you guys, this is a cross-platform application, and it's targeting the Windows and the Android platform. The application is called image manipulation. And what it does is that it takes a live camera feed, and it's able to run a variety of image filters on it. You can run image reduction, some cool effects, and all that kind of stuff. And the application filters that I just talked about are cross-platform C++, which makes up majority of this application. Now, to demo this, let me actually start with showing you guys the app itself so you guys can understand where I'm coming from. So I'm going to move back to my micro HDMI here, wake up one of my devices. So this is not an emulator. This is a third-party software that I'm using, which allows me to screencast my app. So let me show you the app itself now. So here we go. Here's the app. So you can see I can take a live camera feed. Let's take this phone, for example. And actually, I can overlay tiles on it, and then I can move these tiles around. Woohoo! I can also do some other cool effects. I can actually go here and now use the morph filter. Morph filter it works better with light. Here we go. Come on. Not good. So the morph filter will actually add the morph effect to your live camera feed. We have also other sensors, like the reduce sensor, which will perform image reduction and so on. And just for kicks, I'm going to keep this back now. Just for kicks, we also have exactly the same application running on the Windows device as well. So let's go there. So let me show you that app as well, just for kicks. So that's that app right here. I can actually, again, take the live camera feed. This is going to be a bit harder to do. I can do like image reduction on it, I can do image reduction on it and so on. I can reset it back to RGB. So I can do the exact same stuff that I was doing on my Android application is the point. So with that said, let's take a look at how this application was architected. And as I'm doing that, I will demo some of our cross-platform features. So we're done with this solution. So I'm going to open my next baked solution. So we're currently working on making this sample available as well for you guys. So you guys can go ahead and online and download this. It is currently not available online. So let's take a look here. As I mentioned, the image manipulation app is a cross-platform C++ application. It targets the Android and the Windows platform. If you take a look at the library in the image filters library folder here, you'll see two projects. You'll see the image filters Android project, and you'll see the image filters Windows project. Both these projects, essentially, for example, the image filters Android project, reference the image filters.shared component. And this shared component, essentially, which is right here, is all the cross-platform C++ code. So all this code here is cross-platform C++. And it's getting referenced both in the Android project and the Windows project. Let's actually go ahead and build this now so you guys can see what happens when I build this. In the meantime, I will remove my filters file here. And let's go ahead and build this particular project right here. Let's rebuild it. It's already built. Here we go. So notice as we're building it, it will actually start with building all the cross-platform code here. So if you take a look here and you compare this to this output, this is actually pretty much the same. So it builds the shared code component, and it also builds the Android-specific piece of code. So it's building all the shared code right here. For example, the filters.cpp, histogram CPP, and then it builds the Android-specific code component, and then produces us a .a file or a static library. If I now go ahead and build the Windows project, which also references the shared component here, you guys are going to see exactly the same thing as well. It will also build the shared code here using a different compiler. This is using the VC compiler now. All the shared code here. And it will also then build the Windows-specific piece of code, which is actually right here in the Windows project itself. this is also building a static library. These static libraries are then used in these projects here, for example, the native activity and packaging project, and the image manipulation Windows set of projects here to build the end-to-end Android and Windows application. So using this kind of approach, you can actually share your cross-platform C++ code using this kind of a project structure. Also, if you notice, this solution has two projects, Android and Windows, and it's building an Android and Windows app. I can actually go ahead, right-click on the solution, and build for Windows and Android simultaneously. This will take some time. So at this point, I will look for some questions. Do you guys have any questions on how this sharing code stuff works? Anybody in the room? Nope. Yeah, it will generate you all the log files and all that kind of stuff. So the question was, does it actually generate build files and stuff like that? Yes.
So this isn't cross-platform to like Linux, though?
No, it's not cross-platform to Linux yet. I would say not ever, but not yet. Sorry, there's a question in the back of the room as well. Right, so how do you handle the dependent DLLs? So if you notice, there is the Android project itself and the Windows project here. You can actually go ahead, right-click here, go to the property pages, and you can actually go, let's say, in your librarian here. In this case, this is a static library, so maybe not there. But I can go ahead in my native activity project, which is actually referencing the static library that we just built, go in the linker, provide as inputs whatever my library dependencies are. Then I can do exactly the same thing in the Windows project as well, and reference my components. The shared project structure is there for one purpose, for sharing that cross-platform C++ code. And that's pretty much it. It's almost like a folder. We build that code twice using different compilers for Android and Windows. But the beauty of the thing is that you don't have to leave VS. You can, from one click, build the solution, and you get two projects here, two applications here, one for Windows and one for Android. And you can extend this for iOS as well, if you let your imagination stretch. So take a look here. Here's my image manipulation.exe file that got built, which is the Windows application. And here I have the image manipulation android.apk, which is my Android end-to-end application. Does anybody find this cool? Do you think this is good? Woohoo! All right, so the next thing I want to show you guys then is I'm actually going to go ahead and add a new filter here in my shared code. The beauty of C++ obviously is that now that I actually have all this cross-platformness available to me, adding new features is easy because I only have to add them once. So I'm going to go back to my cheat sheet here, copy my code, and copy that into here. Also, while you guys are not looking, I'm going to make some other edits and go back to my filter that I just added. It goes back to filters, go back to find features right here. Notice, as I added this code, you will see multicolored squiggles lighting up. You see the different colors? This is red, this is purple, and so on. I'm colorblind, so I don't see colors that well, but you guys would. Does anybody in the room know what these different kind of colored squiggles mean here? Anybody wants to take a guess? Sir? Red is bad. And purple is good. That's good. No, it's you're close. Does anybody else in the room want to take a shot at this? So the multicolored squiggles that you guys are seeing light up here is because what I've just done is that I've opened up my shared source file, which is filters.cpp, and I've added code there that is not platform agnostic. It is platform dependent. If I hover over these squiggles, you'll notice that when I hover over the Android squiggle, you'll notice here that this is the Windows IntelliSense experience lighting up, and it's telling me that this API message that I've added is actually specific to the Android platform. And the Windows IntelliSense actually doesn't know what this is. Likewise, if I hover over the M128 intrinsic types, this is a language extension that Microsoft provides. And over here, this is the Android IntelliSense experience lighting up and telling me that I don't know what to do with this. This is definitely undefined. So using this experience from cross-platform IntelliSense perspective, when you're working in your shared layer of code, we will be able to save you time by telling your design time that the code that you've added is not going to build, or it's going to build or not build for all your platforms. And this is actually without even compiling your code. Also, something else I should mention here is that if you look at the allocation of this fast feature detector, which is an OpenCV type, you'll notice that there is and there's squiggles appearing here too, both for the Android platform and the Windows platform. That's because I'm actually using different versions of the OpenCV library for the Windows platform and for the Android platform. So at this point, I either have a choice to go ahead and use a different kind of feature detector, or I can actually go ahead and if-def my code. Given the lazy programmer that I am going to if-def my code. So here's my if-defs coming back to life. Notice as the if-defs take effect that currently you'll see the Android section of code fades away. And that's because currently we have chosen the Windows-specific context for IntelliSense. If I go ahead and choose now the Android-specific context for IntelliSense or for our language services, you'll see the Android portion of code is now highlighted, and the Windows portion fades away. So this is essentially one of our value adds that we're offering when you're working in that shared layer of code, to be able to use features like this to help you guys when you're developing that cross-platform layer of C++ code. So for now, I'm actually going to go ahead and build this app. I wasn't nice enough to tell you guys what this app does. What this new filter does. This filter that I just added, what it does is that it takes a live camera feed and it finds interesting feature points. For example, corners and edges and so on. This is kind of like the stuff that you do with real-time computer vision for being able to track object movement and that kind of stuff. So let's go ahead and show you guys the app itself. So for doing so, I'm going to go ahead, set my startup project as the packaging project, which is my Android startup project. As you see, the devices actually change here. It points to my LG Nexus 5 device. I'm going to hit F5 here, which is going to build my app again and deploy it to my device. Those are the security stuff that we need to run. So you can see now that the application is being built and gets deployed to my device. I will bring up my third-party screencast here again, which is going to be friendly with me, I hope, again. Here we go. So that's the app again. And now you can see, oops. Let's go back to the app. Oops. Yeah, I have really fat fingers anyways. Here we go. That didn't look right. Give me a second. Let me kill this app. Let's redeploy it. I'm going to hit F5 again. Here we go. There we go. And notice how when, oh, you guys can't see that yet. Notice how when I'm actually doing this and using that feature, find objects, it goes ahead and doesn't seem to be able to lighting up right now. Oops. We'll have to see, if you see here, it's actually lighting up nicely when I bring the camera close. You just need to focus. Notice how it's actually getting all my source code and lighting up on all the edges and the corners and the text. If I do it on the keyboard, it works better with lighting. You'll notice that it's picking up all the text on my keys and so on. So you guys can see, a live filter that we developed here. Now, how are we doing on time? So we're doing good on time. Great. So when I've actually built this app now and this new filter, I also have this working now for the Windows platform as well. So I can then use the exact same application and run the same find features filter and be able to run and use the same feature I added because I was working in that cross-platform C++ layer again. So that's the end of the second demo. So I'm going to go back to my slides here. I need to remember where I put the slider. So you guys saw in this one some of the feature capabilities, how to build a cross-platform mobile app, how to easily share code between platforms, some of the cross-platform productivity features like cross-platform IntelliSense. I didn't talk about NatWiz. NatWiz is another visual debugging aid that we provide to our users. You guys can take a look at this. This is really useful when you're debugging STL types. If you have a big STL data structure, you have to go through it one by one. NatWiz actually visualizes that information for you, so you don't have to do that. And we also showed here in this demo how to build simultaneously with multiple platforms. So I believe Amanda already did this demo where she showed how to use, or or bring in your existing Android application and then debug it using Visual Studio. So I'm going to skip that. But if you look at the slides, there's all the notes are there, so you guys can do that at home. You can also refer to my blog, which talks about it. Now, so something else that I want to share with you guys today is basically a new announcement that we're making with Visual C++ 2015. There were folks in the back of the room somewhere there asking me questions about iOS earlier. So starting with the 2015 RC build, developers will also be able to leverage our toolchain in Visual C++ to target and build iOS binaries and iOS applications that you can debug and deploy to your device, to the simulator, and so on. You'll be able to not only build these applications, but you'll also be able to edit them, debug them. When we're talking about editing here, you can use all the features that I just showed you from a cross-platform intelligence perspective, from refactoring perspective, and so on. Also, we'll provide you the same cross-platform NES features that I just demoed from a perspective of sharing your code easily across these platforms. So with that said, I'm going to go ahead on the last demo that I have for you guys today, which is building an iOS application now. So what I do with this one. So this application here that I'm going to show you guys now is an OpenGL ES application. It's sharing OpenGL code between an Android application and an iOS application. So let's go ahead and show you guys that now. So in the meantime, do you guys have any questions regarding? Yes, sir. Sorry, I couldn't hear you very well, sir. Yes, you can actually do that. So if you take a look at and you'll see that again in this demo. Essentially, the question is, how do I associate certain build files to be associated with one platform? Is that correct? So the way this structure for sharing code works is that you have an Android-specific project, let's say, a Windows-specific project again, and then you have a shared component. The shared component will include all your shared code. The Android-specific component project will include your Android-specific code. So that's how you would differentiate between the Android-specific sources and the shared sources there. I hope that answers your question, sir. So I'm going to go back here. So here is my Mac that you guys can see. I'm using Parallels here. So let me just bring back my – here we go. So I'm running on a Mac currently, and I'm running VS on my Windows VM. So this solution that I'm showing you guys right now is essentially the File New experience. If you go under File New Project, this is this template right here. There's nothing fancy about this. And what this template is building is essentially a cross-platform application targeting Android and iOS. So if you take a look here again in this project structure now, you will notice in the libraries folder you have an Android native activity project, which references the OpenGL cross-platform app.shared component, which is right here. So it's referencing this source file here. And this project, as I showed you earlier, is building a dynamic shared library, or a DLL, for the Android platform. The other project here that I'm demoing, which is also part of the libraries project here, is the OpenGL ES cross-platform app.ios.static library project. This project here is building an iOS-specific library. It's an iOS static library in this case. It also references that cross-platform code, which is open right here. So for our experience, due to legal reasons mostly, you still need and require a Mac running in the background, which basically acts like your build host, and that's where all the action happens. But you can, as you can see, you can actually code, debug, build everything inside of Visual Studio. We take care of pairing that, and we take care of bringing the error messages back, and so on. Now, let me show you guys some of the source code here. So for doing so, I'm going to go back to my image filter. Sorry, wrong computer. I'm going to go back to my OpenGL ES cross-platform app.shared component, and I'm going to bring up cube.c. So also, I'm going to make sure that I choose the static library or the iOS specific intelligence experience here. As I go to my cube draw method in this case, you'll notice that we've actually done the work to bring up the intelligence experience for iOS as well. all the other language features that you guys are used to on the Windows platform, and now, hopefully on the Android platform as well, work here as well. For example, I can go ahead and say, show me the definition of this particular type, and peak definition will work for you. So that's some of our language services feature. All other features like refactoring and all that kind of stuff works here as well. So let's now go ahead and build this iOS app, right? So for doing so, I essentially have, I'm going to move out of the, wrong computer again. I'm going to move out of the shared space here and show you guys something else now. So as soon as you guys can see that, all right. So here I'm going to start up my VC Remote, which is essentially a Node.js-based agent which listens for requests from my Visual Studio instance. I'm now going to go back to my Visual Studio, and I'm going to go ahead and say that please build me my iOS application. As this app is getting built, you'll notice the output window. Let me bring this back. You'll see in the output window that this is actually building my iOS stuff here for me. So in this case, both the projects that we had, which is the iOS application project and the iOS static library project, got built. Next, I want to show you guys the debugging experience. So for doing so, I'm going to set up a breakpoint here, and I'm going to hit F5. Hitting F5 will try to deploy the application, the iOS application on my device, which is right here. You can see a screencast of that right here. Notice that the application at this point is deployed. And if I go back to my demo here, let's continue with that. Sorry. Let's try this again. That didn't work. Let's try to deploy our iOS application again. Go back to my screen. And let's go back to VS now again. Sorry. Yeah, you'll notice that the breakpoint that I set was actually hit. So as you guys can see, not only can we build our iOS applications, we can actually also debug them using Visual Studio. So because this is the first, this is actually the first occurrence of the breakpoint getting hit in the cube.draw function, when I actually hit continue, this is the first time the shape on my device will be rendered. I'm going to keep hitting continue here. Oops. Let's try this again. Sorry. The screencast wasn't actually working while the debugging experience was working. So what's happening here when we're actually building this application is that in secret, what we're doing is that we're taking the VCX project, which is the iOS static library project, and the iOS application project, and we produce an Xcode project out of it. Then we take that Xcode project and we pass that over to our VC Remote tool that's running on the Mac, which is our build agent running on the Mac. It takes that Xcode project, builds it, produces the IPA file, and then we can take that IPA file and we can deploy it to a device or a simulator. You can do all this stuff from VS. You can debug it, you can build it, and so on. Sir, yes?
What about building the UI?
So,
Do you do that on the Xcode side, or did you build the UI?
You're right. So that's actually a great question. So I'm glad you brought that up. So let me go back here. So what about building the UI? So currently, the bits that we're offering for our iOS experience are, this is kind of like our current thinking at this point. So you'll see that we have a good story for C++. But as far as the story for building your storyboard and Objective-C is concerned, we don't have a great story there yet. But we allow you to basically build your Objective-C code here in VS as well. But we yet don't have like storyboard integration and stuff like that. So you'll notice here in this particular case that this is the cross-platform iOS application project, and it references the static library. So this project right here takes the static library that was being built by the iOS static library project, and once it consumes that, it actually builds the Objective-C code, which is right here in the appdelegate.m and the gameviewcontroller.m and so on. Also, you'll find here the main storyboard, which is here in this template. So what we're really doing here is that we've already created this project in Xcode in this particular case. But if you have like a really heavy C++ application, then you probably have very little, you have a UI container with an OpenGL rendered surface perhaps, and then a thick C++ component there. So you guys can use this experience for now. But again, these are our preview bits over the upcoming releases, we'll be working on preparing a story which is more robust and a complete story for iOS. But this is our current line of thinking. We still want you guys to try this out and give us feedback because that will help us. So I'm going to go and try the debugging experience again one more time because I couldn't show that properly. In the meantime, do you guys have questions? Please keep them coming now. So we're almost at the end of this. So, sir, yes, sir. Right, so the question is, if I want to be able to run this on a Mac server, like build on a Mac server.
Obviously, say like a cloud Mac service to host Linux. How much bandwidth is that?
Right, so I think it's definitely possible. I'm not sure like if it's legally possible. I think some of the iOS EULAs don't allow us to be able to do that scenario, but I could be wrong there. But definitely, I mean, I don't have the answer from a perspective of like how much bandwidth do you need. But as you can see that, if I go ahead and build this code again, you'll notice that it's actually really, really fast. So what I'm going to do this time is that since my screencast, so notice I actually hit the debugger. I wanted to show you guys the debugging experience again. So let me just try to minimize this parallels window and make sure my screencast is running correctly. So yeah, I can either currently work on my parallels window or the other. That's sad. So, and my machine's now home. That's not good. Anyways, is there other questions you guys have? Someone?
Yeah.
Sir?
Earlier you said that you can't do Java debugging yet for a but can you do code editing and actually color syntax highlighting Java?
Right. So, yes, you can't do debugging yet, but you can currently as the state is in RC, you can actually open up your Java source files and edit them as text files. But that is something that we're thinking about very seriously. We haven't yet made them into the live product bits, but that's something that could change in the upcoming releases. Are there other questions, sir? Sir, yes, sir. So the question is there a plan for the UI editor for the Android platform? You said. Currently, I think from a priority perspective, we might look at Java first and then a UI. But I mean, I wouldn't say no here. I mean, a year ago, we wouldn't even dream to have Clang LLVM toolchain, running inside Visual Studio in parallel with the Clang with our own compiler and toolsets. Sir, yes, sir. This currently only works for iOS. The question is, does this actually enablement work only for iOS, or does it work for Mac, OS X, and so on? It currently only. This is our preview bits again. And we currently only support developing for the iOS platform. Yes, sir, at the back of the room.
Do you provide an API for developers who like have a sound access or access?
Right. So the question is, do we provide any APIs that you guys can essentially use as a platform abstraction layer? Is that correct? Is that the question? So yeah, so currently, I mean, our story, like how many people in the room actually know about Xamarin here? People know about Xamarin, right? So Xamarin actually is a very popular solution these days, providing you a platform abstraction layer in C#, right? Our approach is actually a little bit different. What we provide is the ability, since C++ is actually supported on all these platforms, we provide you the ability to target and use that toolchain, but we don't necessarily provide you the ability to be able to, use a platform abstraction layer. So that's basically, so we use the Clang NDK toolchain that Android provides, or the GCC toolchain that Android provides. We use the Xcode build and the Xcode toolchain with the Apple Clang LLVM compiler that they provide and their set of APIs, and that's basically our story for now. So there are other questions. I saw like various hands here. Yes, sir. Right. So the question is, can I actually use the stuff that I demoed to build Cordova plugins? The answer is that we currently haven't been able to do that. It is something that people have asked us to do, but we haven't yet been able to do that as our priorities have been a little bit different. But if you guys feel so strongly about this, you seem like a very interesting guy to talk to, so please come and talk to us about this. Other questions? There was a question in the back somewhere there. Sir, I couldn't actually.
The Studi line, you mentioned what's compatible with have issues as opposed to deal with multiple processor architectures. So let's say I use something
Right. So the question is that the cross-platform intelligence experience that I was lighting up there, is that actually operable, and does that actually work for even different processor architectures like x64 and x86? So currently, this feature is only supported at a platform level, sir, but it is not beyond the realm of imaginability. That scenario should be possible. Other questions that you guys have? Sorry. Yes, sir. Right. So the question is, does Clang come bundled with Visual Studio? Absolutely. So if you bring up the Visual Studio installer now and you go into the optional packages, if you choose the cross-platform node, you will see that there's an option there to install the Android NDK. And once you install the Android NDK, you will basically install the Clang LLVM that comes inside the NDK as well for targeting Android. Are there other questions in the room? So I just wanted to quickly show you guys the debugging experience. Again, sorry about that. I keep switching away from this. So notice like how the breakpoint that I set in my cube draw here was actually hit. And I can actually hit continue, which will run my app. As you can see in the background, I can actually run my app frame by frame here. You can see that as I'm hitting continue, my app is actually running frame by frame. This is basically debugging from within Visual Studio, your iOS application. I can also set other breakpoints here that actually get hit here. There we go. All the experiences that you guys are used to today on the Windows experience from a debugging perspective, like debugging locals, autos, a watch window, all of those things are supported. In this particular case, I have the rotation variable here associated with my watch window. And notice that actually work between the different passes as we go through the render loop in the cube draw function here. Also, the other windows like call stack, breakpoints, all that kind of stuff that you guys are today used to doing on the Windows experience from a debugging perspective is actually available for iOS as well. So we would love to hear feedback from you guys on iOS and the toolchain that we have to provide here. With that said, I just have a few more slides, and you guys keep the questions coming. So I know that there was other people in the room that were asking questions. Yes, sir? There is currently not support for working with existing project. Again, this is kind of like our preview bits. We've been working on this for very hard. Imagine building up a remote intelligence engine. Imagine building a remote build engine and all that. But now that we've got that going and we've been able to launch this for you guys, and the debugger works and so on, as you guys can see, those kind of scenarios are absolutely our priority scenarios for us. There's other questions at the back of the room. Sorry. Yes, sir. We support Neon, yes, sir. So you can actually look at our property pages. We allow you to choose Neon instructions or different or AVX instructions on the Intel hardware and so on. So you guys can just change properties in property pages and be able to leverage those features. So I'm almost out of time here. I just want to mention that we also have an integration point with Xamarin. Amanda in her talk about this. You can read my blog there. So now when you're actually working with Xamarin and creating a C++ code, you don't have to go to another IDE to do that. You can actually do all that within Visual Studio. You can also debug the Xamarin Android native code that you're writing, the C++ code that you're writing, which is being referenced from your Xamarin Android project. You can debug that in Visual Studio as well. So we've worked with them in order to do that. You can read my blog for more details there. You can follow us on the visualstudio.com page and our blog, which is the MSDN blog that we have for VC. We talk about all our new features there. The visualstudio.com page there is about an all-up about what this product provides from a functionality and a feature perspective. As new features come in, those things will be updated. And that brings me to the last slide here that I have, which is about evaluations. So please help us here to understand how we can do better in presenting the material that we have for you guys, and help the speakers to be able to be better prepared next time if you guys have feedback. So please go ahead and let us know how we can learn and improve. So with that said, that's all the material that I had to present. I will be offline, off stage here, and you guys can ask me any questions you guys want. Thank you.